Here is homework 11, problem 2. We have 3 equations. And we must prove which function f we may represent the autocorrelation function of a WSS stochastic process or a spectral density function by setting V equals W. So for the beginning, we should talk about the characters of the spectral density function and the autocorrelation function. And we know that for the autocorrelation function, we know that first r tau must less than or equal r0, and it is even, and r tau is even, and its Fourier transform is non-negative. And for the spectral density function, we know that the S omega is non-negative. And we can use this to prove the following. So for the first one, Fv equals e to the power minus v absolute value. We know that because the absolute value, it obviously that it is even. And for e, we know that it is always less than e to the power 0 absolute value. And it satisfies these two conditions, and we must to show that its Fourier transform is non-negative. Its Fourier transform is over alpha square plus omega square, and obviously it is non-negative. So Fv could be r tau. And second, we know that E minus omega absolute value always more than or equal to 0. So F omega could represent a power spectrum. And the second one, Fv equals sine v to the square and v square. First, we find if it can represent a autocorrelation function. First, we know that it is even, and we should find when tau equals 0. It equals 1, and it is more than sine to the sine squared tau and tau square. And we should find its Fourier transform. It is a graph like this. Here is 1, minus 2, 2. And it is non-negative. So the strict conditions are sacrificed. So if we could represent autocorrelation function, and we know that sine square omega over omega square always more than or equals 0. So it also could represent a power spectrum. And for the third one, f v equals 1, v less than alpha, and it equals 0, the absolute value of v more than alpha. First, we can find if it could represent an autocorrelation function. So the FV, the Fourier transform of it is over omega. We can find it is not non-negative. So FV could not represent autocorrelation function. And we know that f omega, it have two values, 1 or 0. So it always more than 0. So f omega could represent a power spectrum.